Hello, everyone. Have you noticed the voltage and current values marked on your household appliances? This information is crucial to our daily lives. Similarly, in our theoretical classes, we often mention voltage, current, and resistance. But how are these physical quantities measured? In this lesson, we will learn about the instrument used to measure these quantities, the multimeter. The objectives of this lesson are for everyone to not only recognize the different characteristics between analog multimeters and digital multimeters, but also to be proficient in operating an analog multimeter. Through this process, we aim to enhance practical skills in electrical measurements, laying a solid foundation for future technological exploration and innovation. Distinguishing analog and digital multimeters. Multimeters are categorized into analog and digital types. Let's discuss the differences between the two types of multimeters. Both analog and digital multimeters have their own advantages and disadvantages. An analog multimeter is an average responding instrument with intuitive, visual reading indicators. A digital multimeter is an instantaneous sampling instrument. It displays measurements approximately every 0.3 seconds, and sometimes readings may be very close but not identical. Reading from a digital multimeter is not as straightforward as from an analog one. Analog multimeters generally do not have internal amplifiers, hence they have lower input impedance and a DC voltage sensitivity of 100 kiloohms per volt. The sensitivity to DC voltage is 20 kiloohms per volt. Digital multimeters, due to their use of operational amplifier circuits internally, can achieve high input impedance, often around 1 megaohm or higher. This reduces their impact on the circuit being measured and improves measurement accuracy. Analog multimeters have lower internal impedance and often use discrete components to form current shunt and voltage divider circuits. As a result, their frequency response is uneven compared to digital multimeters, which generally have better frequency characteristics. Analog multimeters have a simple internal structure, which makes them cost-effective, with fewer functions, easy maintenance, and strong capabilities against overcurrent and overvoltage. They are still widely used. In this lesson, we will focus specifically on learning how to use analog multimeters. An analog multimeter is a versatile, multi-range measuring instrument capable of measuring DC current, DC voltage, AC voltage, resistance, as well as some semiconductor parameters and transistor amplification factors. We divide it into 10 parts from top to bottom. 1. Self-locking support stand. This can be adjusted to align the scale with our line of sight, making it easier for us to read. 2. Scale. The scale is marked with numerous lines, each serving a specific purpose. When measuring resistance, we use the topmost line, the first one. Corresponding scale lines are used when measuring voltage and current. 3. Mechanical zero adjust knob. Before taking measurements with an analog multimeter, if we find that the pointer does not rest at the zero mark on the left, we need to adjust it using the mechanical zero adjust knob. 4. Ohms adjustment knob. Used to zero the meter when measuring resistance. When measuring resistance, we need to use it. After selecting the appropriate resistance range, we should short-circuit the red and black probes to ensure the pointer stops at the far right zero mark. If it does not, we perform the ohms zero adjustment. If the pointer deflects to the left, gently turn the knob to the right. Conversely, if the pointer deflects to the right, gently turn the knob to the left. 5. Transistor input terminal. This is used to measure the amplification factor of transistors. 6. Range switch. Adjusts the meter for different measurement ranges. 7. Voltage and resistance input terminals. When measuring voltage or resistance, we insert the red probe into these input terminals. 8. 2500 volt special input terminal, used for high voltage measurements. 9. Common ground terminal, where the black probe is inserted during measurements. 10. 5 amperes current input terminal, used for measuring high currents. In this lesson, we've explored the advantages and disadvantages of digital and analog multimeters, and learned about the basic structure of analog multimeters. It's important for you to remember the functions of each part, so that you can effectively measure physical quantities using these instruments. By applying this knowledge practically, you'll continue to improve your skills in both application and innovation. Thank you all for watching.